And then you have EEPROM, which is electrical erasable program or read-only memory. This one also allows you to erase and write as many times as you want, but it uses electricity instead of the ultraviolet method used in EEPROM. So basically those are three types or three variations of RAM. All right. Next we want to look at cache memory. Now cache memory, which the word there is C-A-C-C-H-E, is pronounced cache, right? Now all system units use cache memory. Cache memory is very fast memory used by the processor. It's faster than RAM, and there are basically three levels of cache: level 1, level 2, and level 3. Cache memory uses static RAM or SRAM, and RAM uses dynamic RAM. So with cache memory, what it is a portion actually of the processor. So you see this little chip where it divides up into all these different things. So on the chip itself, we have a section for cache memory, and it's faster than RAM. So how cache memory works is that it works similar to RAM in that it's going to hold your information for you temporarily, but it's faster, and because it's closer to the processor, it's going to send information quicker to where it needs to go there. Right? So that's cache memory. Let's now move on and look at some key terms you have to look at in terms of storage. The first one is bistable. Now bistable is basically a device that can exist in one of two possible states. It can be in the state of on or off, or 1 or 2. Now an example I like to use is basically you're turning a light on or you're turning a light off. When you turn a light on, you're basically having electricity running through the system, right? So it's in the state of on. When you turn the light off, you're not having electricity running through the system, so it's basically off. So it's in a state of on or off. The next one we want to look at is word. Now word is the amount of bits the computer can process in one operation. So as the processor is going through its operation, each time it goes through its operation, it basically uses a certain amount of bits. So depending on the actions or the tasks it's doing, it can use a number of different words per se. Alright, next look at word length or word size. And this is the number of bits in one word, right? And finally there we want to look at character, which can be a letter, a number, a symbol, a punctuation mark, or a blank space. So when thinking of character, think of your keyboard. On the keyboard you have alphanumeric keys, which are numbers and letters, but you also have these different keys as well, like the space bar, the punctuation keys, and so forth. So they would represent basically a character. Now the last thing we want to look at is our units of storage, and we're going to start with the most basic units of storage, which is bit, B-I-T. Now the word bit there comes from the word binary digit, right? So they use binary digits. So it's a B in binary and the T in digit to come up with the word bit. Now this bit is the smallest unit of storage and is comprised of either a 1 or a 0. So when you're writing representing a bit, you're either going to use number 1 or number 0. The next unit of storage above that, or the second smallest, would be byte, B-Y-T-E. This is a combination of 8 bits, right? So when you have a combination of 8 ones and zeros in any variation, that would be a byte. And now what we want to look at next is this table here. In the table we have the different names of the different units of storage. We have their symbols and we have their equivalent, or what they should be equal to. Now pay attention to not only the names and the symbols, but also what they're equivalent to. So for example, megabyte is equivalent to 1024 KB or kilobyte, right? And as we go down, you will notice that the symbols change, right? So pay attention to that. Now one thing I want to go through in terms of these units of storage is their actual value when looking at them. So for example, a kilobyte will be 1,000 bytes. A megabyte will be 1,000,000 bytes. A gigabyte will be 1,000,000,000 bytes. And a terabyte would be 1,000,000,000,000 bytes, right? Now, terabyte is where we're going to stop in terms of the actual value that they think of them in terms of bytes. But it's just something that you guys need to know. All right. So that's it for primary storage, and look out for the other topics coming up.